the rule for this equation, for finding the slopes of solution curves in this region of the plane, was y prime equals t over 2. That's of the form y prime equals f of ty, with f of ty just equal to not t. You might think I'm making these mistakes just so I can illustrate the need to check, but I'm really making them, so don't make that mistake. Okay, so again, this is the form f of ty with f of ty equals t over 2. And the point is that this function, and let's try not to get too distracted by my repeated errors here, the point is that this function is very easy to integrate. Remember, in solving over here, we simply integrated both sides of the function, and we got easily got the expression for the integral of the right-hand side. So f of ty equals t over 2 is easily integrated. This makes the equation easily solved. So the equation is easily solved in a case like this, when our f of ty function is a simple function of t, something we can integrate, we easily get a solution. Now that's not always the case. Let's look back at the function we started with. You might wonder what that domino laying in the middle of the page is doing there. Well, it's covering up something that I wrote down that I shouldn't have. Just trying to cover up some errors. Look, the point is that the rule for this function is different. It's not just simply a function of t. We can see that the slopes change with y as well as with t. Now when that happens, well, let me just tell you what the rule was for this particular equation. The rule was y prime equals y over 5 plus t over 4. Now if you tried to integrate both sides, well, integrating y prime, which is just dy dt, is going to give us y, and then we want to integrate y over 5 plus t over 4. Well, we get the y here very easily, integrating with respect to t. Over here, we can integrate t over 4 with respect to t, but how do we integrate y over 5 with respect to t? Y is a function of t, and we don't know what that function is. We know y prime as a function of t and y, but we don't know y as a function of t, so there's no way to integrate this y over 5 dt. So what we would get here is this would be the integral y over 5 dt plus t squared over 2 plus a constant. That would be fine, but we can't integrate an unknown function y with respect to t. Now we could integrate y over 5 with respect to y. An antiderivative of y is just y squared over 2. And it would be very easy to integrate if our variable of integration was y. But since y prime means dy dt, that means when we integrate y prime, we're implicitly integrating with respect to t. So we have to integrate this side with respect to t. So there's no simple way to figure out what y is. Now it's going to turn out that we can fairly easily solve this equation. We're going to learn to do that fairly shortly. But right now, unless you've already had an introduction to differential equations and happen to know how this is done, you're probably not going to be able to do it.